Hello everybody, today we're going to be looking at composite area of compound figures. Please pause the video and work on the do now. Okay, now if you're having trouble with the do now, let's just keep in mind some things that we should know about these irregular shapes. One thing that you should know is if you have a side with the same marking, that means that those sides have the same measurement. So the 1 dash is 7 inches on one side, so that must mean that the other side is also 7 inches. Same thing with the sides with 2 dashes. This is 2 dashes is going to be 14, so this side will also be 14 inches. And then finally, another thing that you need to keep in mind is that when you're working to find missing information, so do you see this greenish line that I'm highlighting right here? That right there is going horizontally across the page. So we're going to see what pieces make up that distance. And you're going to find other sides that run horizontally. So here we have 4 inches, 10 inches, and 3 inches. So that means that 4 plus 10 plus 3 is 17 inches. So that satisfies the first part of this do now. The second part is talking about perimeter, and you're going to add all sides to find this out. So when we do this, it will be 14 plus 4 plus 7 plus 10 plus 7 plus 3 plus 14 and finally plus 17. And when you add all of that together, you get 76 inches. Then to find the area, you can either cut off these 2 little smaller rectangles from the bottom, so you'd have 1 large rectangle on top, 2 smaller ones on the bottom, or you could go vertically with the cuts as well. I think I'm going to cut them off going across to get the little pieces like so. Again, this is just personal preference. And to keep track of my work, let's just be really careful here. This small rectangle is a measurement of 7 inches. This full distance is 7. This full distance is 4. So 7 times 4 is the first shape that we're going to be working with. And it's going to be a rectangle. So the area of the first one is length times width, and it will be 7 times 4, which is 28. And that's going to be inches squared. And then we're going to do the same thing for our next little tiny rectangle. We have a 7 and a 3. So we would do area equals length times width, and area equals 7 times 3, which is going to be 21 inches squared. Now, the very last part is a little bit more tricky, and that's because, yes, we do have the long length here of this top rectangle, but I want this little piece right here. Now, this little piece, we need to find this distance. We know the full distance is 14. We know that this shorter distance is 7. So if we take this full distance of 14 minus 7, that means this part right here is going to be 7 inches. So when we do our last rectangle of area equals length times width, it will be 17 times 7. And that's going to be 119 inches squared. So again, 119 inches squared. And then finally, we can add all 3 of these together. And so when we add those together, we get the area is 168 inches squared. All right, this is what we're going to be working on today. We have a whole bunch of these problems, so let's get started. Okay, so we have a whole bunch of these types of problems. You can work independently and then check over your work, or you can watch this video and see the work done out. It's your choice. Now for this next one, I would probably cut the triangle up off the top. Another way you could have done this is you could have created a trapezoid and a rectangle, but either way is okay. I'm going to go with, I think, the triangle, just because I like the triangle formula. All right, so let's be organized with our work. We're going to have the area formula of our triangle, which is 1/2 base times height, and we're going to have the area formula of the rectangle that we created, which is length times width. Let's start with the rectangle because it's a little bit easier. So the full distance across the rectangle is 20. The other side is 8. So it will be area equals 8 times 20, or 20 times 8, which is going to be 160 inches squared. You can label it inside the shape if you'd like. And now for this next part, it's a little bit more challenging. You need to find this distance right here and this distance. So we need to use information about our shape. So let's see here. If I want to find out what this distance is, and I know the full distance is 14. So this vertical line is 14. This vertical line is 8. So 14 minus 8 means that this is going to be 6 inches. And then we'll do the same thing with this bottom piece right here. So if this full distance is 20 and this is 12, 20 minus 12 is 8. Okay, and now we have our dimensions of our triangle, and we can use it in our formula. So the area is equal to 1/2. Our base is 8. Our height is 6. Half of 8 is 4. 4 times 6 is 24. And that's 24 inches squared. Add these two together because it's a compound or composite figure. So it's going to be 160 plus 24, which is 184 inches squared as the final area. Okay, so this problem is asking for both area and perimeter of the figure. Let's start with area. So with our area here, we see we have 2 semicircles. A semicircle is half of a circle. So if you have 2 halves is equal to 1 whole. So when I want to find the area of the semicircle, I can actually find the area of just a plain old circle. Because, again, we have 2 halves, and area equals pi r squared. And then we also have a square, and I know it's a square because it's a 5 by 5 shape, and so that means we have area equals side squared. Let's put in our information here. For the circle, area equals pi. Now we want our radius. Be careful about this. See this 5, how it goes all the way across the circle? Since it goes all the way across the circle, that 5 is actually a diameter. If our diameter is 5, that means our radius is 2.5. So when we put this in our formula, it'll be 2.5 squared. 2.5 squared is going to be 6 25/100ths. Keep your pi. And then since it says that we want it to the nearest hundredth, we're going to multiply that by our pi in our calculator, and we get 19, and it's going to be 0.63. And then for the area of the square, it's going to be 5 squared, which is 25. You're going to add both of these numbers together, 25 plus 19.63. And when you get that, you end up having an area of 44 63/100ths inches squared. Now, for the part that says perimeter, what you would do is if you have half of a circle's perimeter here and half of a circle's perimeter here, to find the full perimeter, that's actually 2 halves again, which is going to be a whole circle. So circumference equals pi d, and then we also have this distance here, which is 5, and this distance here, which is 5. So it's going to be circumference equals pi d, and then it's also going to be plus 2/5. So again, our diameter is going to be 5. So it's 5 pi plus 10, because remember those two added together is 10. And then we'll type this in our calculator to get our final answer, which is going to be our total perimeter is 25 and 71 hundredths inches. So again, just as a reminder, you can follow along with this video to work your way through the packet, or again, you can work at your own pace and check it over once it's done. There are a total of 9 examples in this packet, and this was number 2, so let's keep moving. All right, this next type of problem is one of my favorite. It says find the area of the shaded region to the nearest tenth, which means we want to find the area of the pink part of this problem. Now you're going to see that there's actually 2 shapes. There's a square, a big pink square, and then there's a little tiny circle. And you're going to notice the circle does not have any coloring in it, which means it's a cutout. You want to remove this area from the area of the square. So when you do that, you'll start by first finding the area of the square, and we're going to substitute our information of 25.5 squared. That leaves us with the area of 650 and 25 hundredths inches squared. And again, that's the area of the square here. Should label that. Now to find the area of our circle, again, pi r squared. Substitute this in. We know the radius is halfway through the circle, so that 4 and 25 hundredths. And type this into our calculator. And it also says to the nearest tenth. I'm going to leave it to the nearest hundredth until the very end. And the area of our circle is 56. Oops, there we go. 56 and 75 hundredths. Add these two together. So 650. Oh, wait, no, not add those two together. Silly math teacher. We're going to subtract them, because remember, it is a cutout. So we take these two numbers, line them on up, and subtract. And when we do that, we end up getting 593 and 5/10 inches squared as being our final answer. All right, up next. Again, here's another shape that has a missing chunk. Now, if you're taking a look at this, technically there should be a little tiny right angle in this section. And by having that there, you know that this is 1/4 of the circle is missing. Because if I were to be taking this right here, I could actually break this up into different sections. So 1, 2, 3, 4. Now you have 2 options to do this problem. You can find the area of the full circle and then find the area of the quarter circle and subtract. Or you can use the idea that there's 1, 2, 3 parts that are filled in our circle. So when we do our area formula of our circle, it's actually not of our full circle. It's going to be of a quarter circle. No, 3/4 circle. There we go. So 3/4 of the circle is shaded in, and the area formula is pi r squared. And so we'll do that. We'll do 3/4 pi. Our radius is this 17 number squared. And it says find it in terms of pi n to the nearest hundredth. So to find it in terms of pi, what I'm going to do is I'm going to type this 3/4 of 17 squared into my calculator first. So we end up getting 216 and 75 hundredths pi. And it also says to the nearest hundredth, so I'm also going to multiply that by pi, which is going to give us 680, and it says to the nearest hundredth, so it'll be 94 hundredths. And that's going to be inches squared on both of those. Now, to be honest, this is a little bit challenging for the perimeter, but it's the same idea. You are going to find the circumference, I should say, of 3/4 of this circle. So it's going to be pi d. And when you do that, that's this curved part right here. You also want these two radii, which is going to be 17 plus 17, which is 34. And we'll substitute in 3/4 pi. Well, if our radius is 17, that means our diameter is 34. Now, this is a little challenging, so if you're struggling with this, don't worry. We're going to be working more on this again tomorrow. But again, so 7/500, or 3/4 of 34 is going to be 25.5 pi plus 34. This is actually how you would leave your answer in terms of pi, but we're not going to leave it like that. Now, taking that final answer and typing it into the calculator. And our final answer is going to be 114, and it says to the nearest hundredth, so it'll be 11/100 inches. And again, if you struggled with finding the perimeter of this figure, again, don't worry, we will work on this again tomorrow. All right, so next up we have this rectangle with a semicircle cut out. So if this side right here is 10 inches, that means that this side on this opposite is going to be 10 inches as well. And now here's the tricky part. You actually want to find out what this distance is across from the semicircle. So again, if this full distance is 18 and each of these are 3, 18 minus 6 is meaning that this is a full distance of 12 inches. And that's going to be important in a little bit. So now for area, let's start with the area of the rectangle. That's a little bit easier. And the area of the rectangle is going to be 18 times 10. So 18 times 10, which is going to be 180. And that's inches squared. Now we want to find the area of this semicircle. And a semicircle is just half of a circle. So it'll be half pi r squared. Half pi. Now again, this is the full distance across the semicircle. So halfway across means the radius would be 6. 6 squared. And it says to the nearest inch. So we're going to type all of this into our calculator and make it do all of the work for us. So when we do that, we end up getting an area of about 57 inches because it says to the nearest inch. And you're going to add these two numbers together. When you do that, you get 237 inches squared. Now for perimeter, we're going to do the same thing as before where we're going to add up all of our sides. 3 plus 10 plus 18 plus 10 plus 3. If I add all of those together, that's going to be 44 inches. But now we need to find this curve right here. And see how it traces along the edge of the semicircle? That means it's going to be half of the circumference. So to find that, it'll be c equals 1/2 pi d. And again, I have these formulas from my formula sheet. I'm just taking the circle formula and cutting it in half for a semicircle. So it's 1/2 pi. Our diameter was 12. So that's going to be 6 pi. And 6 pi in the calculator is going to be approximately 19 inches. So it'll be 44 plus 19. And that adds up to 63 inches. And that's going to be your perimeter. So again, our perimeter is 63 inches. Our area was 237 inches. Okay, so I see 3 figures in this one. I see a rectangle, which is length times width. I see a semicircle, which is 1/2 pi r squared. And I also see a trapezoid, which is the formula of 1/2 base 1 plus base 2 times your height. Starting with our rectangle, I know this looks like a complicated shape, but it's actually labeled really nicely. We have 9 times 3.5. So 9 times 3.5. That is going to be 31.5 inches squared. Now for the next part, we have our semicircle. Now this distance is across from this distance here. So if this is 3.5, to find our radius, it's going to be half of 3.5. And half of 3.5 is 1.75. So from here to here, it's 1.75. And we'll substitute that in. Use our calculator. Now I just realized that this area problem is not saying what to round to. So we'll just round to the nearest tenth. And finally, let's fill in the information for our trapezoid. Okay, and we get 23 and 25 hundredths. But again, we're going to round to the nearest tenth. And I chose the nearest tenth because the 10th place was the one that was shown in the actual problem. So let's add all of these together. And we get a final answer of 59 and 6/10 inches squared. We're doing great. Let's keep going. All right, so this is a little bit more challenging of a problem. Here we have a rectangle and 3/4 of a circle. The area shouldn't be an issue. So when we are finding our area, again, area of the rectangle is length times width, and area of the 3/4 of a circle is going to be 3/4 pi r squared. So if we're taking a look at our rectangle, this is 5, this is 15. Let's substitute that in. And we get a total area of 75 inches squared. And now for the next part, it says find the area of the 3/4 circle. Now, if this distance is 5 right here, that means that this distance is 5. So that's going to be our radius is 5. So 3/4 pi 5 squared. And it says to the nearest inch, so we'll use the calculator. And that gives us 59 inches squared. Okay. And finally, add those two together to get your final area, which is 134 inches squared. Okay, so now for the perimeter of this figure, let's start with the circle. Again, we have a circumference 3/4 of the circle. It's going to be 3/4 pi d and 3/4 pi, and our diameter is going to be 10 because if the radius is 5, that means our diameter is 10. So that means the circumference of 3/4 of this circle is approximately 24 inches. Now we need to find the other parts of the rectangle. This part is 15. This part is 5. Now this is a little bit more challenging right here because it's not labeled. But again, see how it's horizontal? What else is horizontal is this 15. So the full distance across is 15. So this full distance across is 15. But we know the radius is 5. So if this is 15 and this is 5, 15 minus 5 is going to be 10. And do our calculations. And we get a final perimeter that is about 54 inches. That was really a challenging one. All right, we're almost there. 2 more. Okay, so we have some pieces removed from a rectangle here, and it looks like it's 2 semicircles. Remember, 2 semicircles is the same thing as 1 circle. So when we're doing this problem here, we're going to have the area of the rectangle, and we're also going to have the area of a circle. Now for a rectangle, the length is 50, the width is 24, so it'll be 50 times 24. That's going to be 1,200, and it's 1,200 inches squared. Okay, this is the part that gets a little bit more challenging. If this full distance is 24, that means that this full distance is 24. If this is 24, and these two little pieces are 2 each, 24 minus 2 means that the distance across the semicircle is 20. So let me mark that right here. That's going to be 20, and that's our diameter. So our diameter is 20, which means our radius is 10. So that will be pi 10 squared. And since it says to the nearest tenth, that is going to be 314 and 2/10 inches squared. And again, those semicircles, those two semicircles create one full circle. So that's why I'm doing the formula of one circle. And then we're going to cut that out by doing the 1200 minus 314 and 2/10. That leaves us with our final area as being 885 and 8/10 inches squared. Okay, and then for perimeter, it's going to be the same idea as what we've been doing before. We're adding up all the sides. So it'll be 50, and then there's another 50 on this side. Then it's going to be plus 2 4 times. So 2 times 4, that's going to be 8. And then it's also going to be plus our circumference. So we have to calculate that. Pi d. C equals pi d, so C equals pi, and our diameter was 20. So 20 pi is about 62 and 8/10. So add all of this together of 50, 58, and 62 and 8/10. And our final answer is the perimeter is going to be 170 and 8/10 inches. All right, one more. You can do this. I'd really like for you to try this one on your own first before watching this part of the video. So pause now and try that, please. Okay, so it says find the area and perimeter of the given figure to the nearest hundredth of an inch. I see two shapes. I see a square, and I also see a semicircle. And we know semicircles are half of a circle. So it'll be half pi r squared for the area. And the side of the square is 23. So 23 squared is going to be 529 inches squared. And then we'll substitute in for our semicircle. Now, again, if this full distance across is 23, this full distance is 23. So to find our radius, we would do 23 divided by 2, which is 11.5. So it'll be 11.5 squared in our formula. And when we do that, we get 207. It says to the nearest hundredth, so it'll be 74 hundredths. And you'll add these two values together. And so the area of this composite figure is 736 and 74 hundredths. Now let's look at our perimeter and then we'll be done. So for our perimeter, we're going to add up all the sides. We have 23 3 times. So 23 times 3. And we have half of the circumference. So half of pi d. It'll be 23 times 3 is 69 plus half of pi times the diameter, and our diameter was 23. So it's 1/2 pi 23, and our calculator says the answer is 36, and it says to the nearest hundredth, so 13 hundredths. And add these two together, and that will be your final answer of 105 and 13 hundredths inches. All right, I know some of the problems in this video were challenging, but the main idea is to know that you're going to find the area of each piece of the figure, add it together to find your composite area. For perimeter, you add up all of the sides. All right, that's it. If you did not finish this, make sure you have it all done by tomorrow. Have a great day. Bye.